When I see parallelogram, this is what goes through my mind. In my mind, I actually draw a picture with some degrees in it, and I do something like this. That's actually the first thing I think about, is what kind of degree pattern is there. The opposite ones are equal, and what do the consecutive ones add up to? 180. So I think of that immediately. Then I think to myself, what's going on with the diagonals? The diagonals bisect each other. I also think to myself of Z shapes, alternate interior, and I think of C shapes, which would be our consecutive interior. And when I'm thinking about those shapes, I think of equal angles for the alternate interior angles, and I think about 180 being inside that C consecutive interior shape. That's what goes through my mind when I think of a parallelogram. When I think of a rhombus, this is what I think of. I think of a series of drawings. I think of what it looks like without any diagonals. It's got 4 equal sides. And then I think about what it looks like with the diagonals. The diagonals are perpendicular. So I put in, let's make this a little bit bigger. So I got that, and then I put in right angles in the center. So I think of a rhombus in terms of pictures. Right angles in the center, I look at that, and I throw in a couple angles. 40 and 40. That's not necessarily true for a parallelogram. You won't always see the two angles being the same when the diagonal splits them. So for this type of drawing, it might be 30 and 50 for a parallelogram. But for a rhombus, I know those two are always going to be the same. I know these two are always going to be the same. So when I think of rhombus, that's the picture I think of. 4 sides equal, right angles in the center, and I know these angles that are next to each other are always the same. For a rectangle, I think to myself, it's very symmetric, and diagonals are equal, same length, and we get a bunch of isosceles triangles in the mix. So I think of that. I think of all those pieces being the same, which creates isosceles triangles. I know everything's symmetric because it's got right angles here. That's the picture I think of when I think of a rectangle. And a square, I just think of everything, because a square is everything. A square is a rectangle, it's got all this. A square is a rhombus, it's got all this. A square is a parallelogram, it's got all of that. The rectangle and rhombus are also a parallelogram. So all of these are parallelograms, and they have all of this introductory info. So when I get to question 1, which says, which of the following is not a parallelogram, the ones I just talked about are parallelograms. That must be trapezoid. This is a parallelogram. If you look up top in my diagram for parallelograms, we knew that these two angles got to be equal. If you set up that equation, then 4x equals 36, x equals 9. We're not looking for x. We got to put that back into here. 9 times 10 is 90 minus 30. That angle is 60. I'm still not looking for that angle. I'm looking for the angle down here that's supplementary. as soon as I see the rectangle, I do that. The diagonals are equal, but not only the diagonals equal, the parts of the diagonals are equal. That creates some isosceles triangles, so if I've got 50 right there, that's within an isosceles triangle. That leaves me with 65 for here and 65 for here. Rhombus. The picture I have in my mind of a rhombus is that all those sides are equal. I know that 40 goes up here. And within my rhombus picture, I said that the angles next to each other are the same. These two are the same as these two. The only thing that'll work in that combination would be to have 70 degrees in each of those spots. This is just opposite angles being congruent. Next page. We want to know what's not true. Take out your polygon packet for a moment. In your polygon packet, you have notes on the left side of every single page. On the very first page, you have all of this information about quadrilaterals. The next page probably has stuff about squares and kites and trapezoids. Make use of it. Look through these summary note sections if you're looking for something to study. Does any of those characteristics mention complementary? What does complementary mean?
Add up to 90.
Add up to 90. And that's the one that's not true. Everything else is true. Don't get scared if you see coordinates like in number 7. You will have graph paper, so you could theoretically plot these points. If it's a rhombus, what was my picture of a rhombus? What was the first thing I put into it? I did that. All those sides got to be equal. If things are horizontal or vertical, isn't it very easy to figure out what that distance is? If it goes from 0, 0 to 5, 0, what is it? 5. So the distance up here has got to be the same. It's horizontal. The y coordinate is not changing. It's still going to be 4. But it's going from a 3 over 5 units. So where does it end up? Parallelogram, which would be sufficient for rectangle. What did I write down in my rectangle notes on the opposite page? What did I write down? Let's see, diagonals equal. Come back over to here. If I actually drew in the diagonals, that would be AC and BD, and they would be equal. That's the very first line. That's enough to prove that it's a rectangle. The other ones might be true. AB is equal, let's see, AB, AD. Well, not necessarily true. Angle B and angle D. Angle B and angle D, they could be equal, but it doesn't say anything about them being 90 degrees. And the last one, A and D being supplementary, that's true, but we don't know the specifics. We don't know if they're both 90 or one's 100 and one's 80. The first one is the only way to prove Be careful with this type of problem. This one is telling us, look in the first quadrant. So it's narrowing down our field of vision to something that's over here. Use rise and run. Over 4, up 4. Over 4, up 4. So the actual diagram would be that. I'm looking at the rise and run. It's a parallelogram, so those slopes have to be the same. That takes me to 9, 4. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. If it didn't say quadrant 4, there'd be more answers. I don't just have to put something there. I could have put done this. I could have dropped down 4 over 4, dropped down 4 over 4, and I could have created my parallelogram that way and have a fourth quadrant answer. Or I could go up in this direction. This is over 2, up 1, 2, 3, 4, 5, 6, 7, 8. Over 2, 1, 2, 3, 4, 5, 6, 7, 8. So it would be up here someplace. That could complete a parallelogram. So pay attention. If it gives you a quadrant, great. That narrows down your choices. If it doesn't, then you have 3 possibilities. This is just a parallelogram. I see some Z-shapes in here, so I can put 44 up here. 56 goes here. What's left for DEF? That looks like 80. Keep your polygon sheet out. Lydia just pointed out that there's a mistake on the P.